if we use them anywhere inside a member declaration, so that we don't have to manually create a constructor, copy the values to local fields, and then return the field. So we have a type declaration here. We can of course use F# interactive to test it. And to create a new instance of the feed item, we'll call it F1, for example. We'll use the new keyword, so you can see that the syntax isn't very different from C#. So let's create an instance with some title and article description here. And now we have a instance of the feed item object in the F# interactive window, so we can access its members such as title and also description. The next thing that we will do is that we'll replace the use of tuples in the existing code with the class that we've just wrote. So here is a location where we originally created a tuple, and we'll use the feed item type instead. Of course, we'll have to adjust other parts of the code as well. So here, when we were using tuples, we'll now use the feed item object, and we'll use the title or the description when searching for the keywords. You can see that F# underlines any problems, which is very useful. We can already see when we have a problem in the code. So now the code should be working, and let's take a look at the return type of the search items. Now the type gives us a little bit more information because it's a list of feed items. So when the C# user gets the type, he will already see a little bit more about what does it mean. So if we look at the return type of the search items now, it's an asynchronous workflow that eventually yields a list of feed items. Instead of returning tuple, the C# user will get a feed item objects which have some standard .NET properties. Now, as a next thing, we'll declare a feed search type, which will be the main class that the user of our library will use when working with RSS feeds. The feed search type will take the list of feeds as an argument of the constructor, and we'll specify that the type of the feeds is sequence of strings. The seek type, which you can write like this in F#, is actually standard .NET I enumerable type, so the use will be very natural from C#. And we had these two functions, download URL and search items. And when we wrote them, we just wrote them inside the script file and used them from F# interactive. Now we want to use them as a part of the feed search type. So we'll indent them a little bit further, and that turns a function that we originally had into a private method of the feed search type. So both download URL and search items are now private methods of the feed search type. And we can use them when writing public members. So we'll add one member to the end of the code, and let's call it search. And the member will take a list of keywords. It will take a single string that will contain keywords separated by spaces. So we'll take a string keywords as an argument. And inside the search member, we'll just run the code that we already wrote here in the previous webcast. So we'll start downloading items from all the feeds in parallel and processing them to find any of these keywords. And we'll need to pass the keywords to the search items function, so let's modify the function a little bit. So the function will now also take a keyword array as an argument, And we don't need to specify the type because the F# type inference will figure that out automatically for us. And when we'll call the search items function here, we'll need to specify the array. So let's create keywords array here, and let's just call the split member using space as the separator. And we'll add keywords array here. And now we have an F# type declaration, which will be compiled into a standard .NET class that anybody can use. We'll do one more improvement before trying the class using F# interactive, which is that if we look at the search member, you can see that it returns a list of feed item. We can of course use F# lists from C#, that's not a problem, but it's not as comfortable, and the C# user could be a little bit confused by seeing some unfamiliar type. We can add one more function call to the pipeline here, and we'll call the function named seek of list, which is a very simple function that turns a list into a sequence, which is a .NET IEnumerable type. So now the return type is sequence of feed items, which should be pretty easy to use from C#. So let's select the whole class and let's see if it works from F# interactive. I forgot to execute these bits of code, which means that the compiler couldn't find some of the types that it needed, but it should work now. So let's select the class again. Let's compile the class in the F# interactive window, and let me also enter this bit of the code, which creates feeds value so that we can use these feeds as an argument when creating the class. So let's type new feed search, and let's give it these feeds as an argument. Now we can use the search method to, for example, look for all the posts that mention F#. And here we go, we've got one item that mentions F#. Now as a next step, we'll want to use the code that we wrote and compile it into a standard .NET library that can be used, for example, from C#. So I'll just copy the whole code that I wrote. I'll save the file in case I needed it later. And let's create a new project. And we'll select an F# library, and we'll call it, for example, RSS feeds library. Now the F# creates a couple of templates for us. So we'll have a script file which we won't use because that's used only for testing the library. And we have a file called module.fs where we can paste all the code. Now, as you can see, we have a couple of problems. The first problem is that we are not referencing the XML library. So let's add reference to system.xml to the project. Because when we are working inside a project context, the source code takes all the references from what we have as a reference in the project. We also can't use #r directives, and instead we'll need to add a reference to the F# PowerPack library. So let's find the library here, and now the code is almost complete. There's one more change that I wanted to do, which is to specify a namespace for the types that we have here. This can be done just by writing namespace to the top of the file, and we'll call the namespace also RSS feeds library. Now, when we are writing a code inside a namespace, we can't have global let bindings, so I'll just remove the let feeds declaration here. And now we should have a code that we can compile. So let's try building the library. And as you can see, it compiled pretty well.